In this movie, I want to have a look at the call stack, which effectively gives us a breadcrumb trail of the execution of our program throughout its functions. So if we have a question such as, I've reached the breakpoint, but how did the execution of the program ever get here in the first place? The call stack can answer that question. So I'm going to bring MonoDevelop back into view here. So you can see that what I've got here at line 20 is a breakpoint that is marked here. But you'll notice that at this point, at this line 20, we call upon the function 01, which is specified down here, and function 1 calls on function 2, function 2 calls on function 3, and then function 3 finally jumps into here and prints the statement entered function 3. And the call stack will allow us to monitor the flow of execution through those functions. So I'm just going to attach the MonoDevelop here to the Unity editor. So I'm going to choose Run, Attach to Process, choose the Unity editor, and then choose Attach. I'm going to jump back over here to Unity and press play on the toolbar to begin execution here. And again, execution will suspend because our breakpoint has been reached. If I bring back MonoDevelop, you can see that we have reached line 20. We haven't yet entered function 1. Execution has suspended here, and you can see in the call stack that right now we begin here in the start function. Now at this point I could choose step over. If I choose step over, what will actually happen is execution will move to the next line, which happens to be the end of the start function. But if I want to follow execution through into this function call down into function 1, I should instead use the command step into, which is the third one along. So I'm going to choose step into, and when I do that, execution now moves down here inside function 1, and you can see in the call stack here, we are now inside function 1. We reached here because we began in the start function, and then we entered function 01. So you can see this breadcrumb trail here. These are arranged in reverse order in the sense that the top one is the function that we are currently in, and the function below is the function which led us, that is, to get to where we are in the first place. So I'm going to choose step into again. This time I'm going to move into function 2, ready to call upon function 3, and you can see again the breadcrumb trail building up. So we began in the start function, we moved to function 01, and then we entered function 02. And if I go step into again, we're going to go down to function 03. And finally, you can see the trail fully here from start, function 1, function 2, and then function 3. And now, if I choose step over, we end the third function. I'm going to go step over again, and we end up back now at the second function, back down here after function 3 is completed. We reach the end of the second function, and now the call stack is undoing itself, as it were. I'm going to go back to the next one, which leads us back up here. And again, we're back at function 01. I'm going to go step over again, and this leads us back to the start function, ultimately where execution began. So this call stack allows us to get a complete picture over how execution arrives at particular functions, and this can be very useful when you are trying to monitor how your program is flowing at runtime.